And we are live. Alright, this guy right here. I to the 72. Here's what you must know. If you know these two things, that's all you need to know. Definition of an imaginary is the square root of a negative. And the very base unit is square root of a negative 1. So this is the building block of all our imaginaries. But if you ever have an imaginary multiplied by an imaginary, that's going to leave the imaginaries. And that's in the world of the reals. I times I is negative 1. So you know that I squared is negative 1. If you know I squared is a negative 1, the question is, if you have 72 i's, I times I times I times I times I, over and over and over, is it going to end up real or is it going to end up imaginary? If we got 72 of them, is that going to stay in the reals or is that going to or stay in the imaginaries or leave into the reals? It's going to be real. So the question is, how many squares are there in 72? There are going to be 36. Because 36 squares is 72. So you have to think of it in terms of squares. How many squares are in 72? There's going to be 36. And you're going to replace each square with a negative 1. So if you have a negative 1 times itself 36 times, where do you end up? Do you end up with the negative 1 or positive 1? And you should end up with positive 1. 21. Okay, out of the 21, how many squares do we have in 21? So if you've got I squared, if you have 10 squares, that's 20. But there's 21 total, so I'm going to have to account for one extra I. So I squared to the 10th. Now I'm going to swap out I squared for a negative 1. A negative 1 to the 10th times I. A negative 1 10 times is going to be a positive 1. Positive 1 times I is just I. If you got 35 imaginaries, how many squares are in 35? I squared, there's going to be 17, but 17 squares is only 34. So there's a 35, so I got to account for that extra I, and I'm going to replace I squared with a negative 1. So if I've got a negative 1 17 times, I really have a negative 1, and a negative 1 times I is just going to give you a negative I. Last one, if you got 446 imaginaries, how many squares are in 446? So there's 223, and you're going to replace your I squared with a negative 1. A negative 1 223 times is just going to leave you with a negative 1. Okay, imaginary. This will give you an imaginary because it's really this, x equals plus or minus square root of negative 16. This is the square root of 8. That's real, we're okay. This is the square root of a negative 8. That's imaginary. That's real because that's the square root of 16. This is going to be negative 6 times I squared. That's real because an I squared is a negative 1, so that's a positive 6. I times I times I times I times I. That's imaginary because these two are going to be real. These two are going to be real. And a real times an imaginary is going to be imaginary. This is imaginary. If you got 57 of them, that will stay imaginary. If you got 60 of them, that will go real. So you should have circled 5 of them. Okay, multiply each output by 2y. So you're going to do 1 times by 2y. And that will turn it into 2 imaginaries. 2 imaginaries times by 2 imaginaries. that is going to be 4. But an I times an I is going to be a negative 1. So this should be a negative 4. 4 times by 2I should be a negative 8I. A negative 8I times by 2I, a negative 8 times 2 is negative 16, but I times I is a negative 1, so this is going to be positive 16. Positive 16 times by 2 imaginaries is going to be 32 imaginaries. 32 imaginaries times by 2 imaginaries is going to be 64 imaginary squared. But I times I is a negative 1, so it's going to be a negative 64. Negative 64 times by 2 imaginaries is going to be a negative 128 imaginaries. And a negative 128 imaginaries multiplied by 2 imaginaries is going to be a negative 256 imaginary squared. But I times I is a negative 1, so it's going to be positive 256. And 256 times by 2 imaginaries is going to go 512 imaginaries. So it should alternate between a real, imaginary, real, imaginary, real, imaginary, real, imaginary, real, imaginary. So do the same thing. We'll let you do the same thing by 3. You're on your own for that one. Rhett hates it when we skip. He does not want you to do this on your own. No skipping. Multiply by 3i. 1 times 3i. You can everyone thank Rhett for this nice convenience. 3i times 3i is going to be 9i squared. I squared is a negative 1, so it's going to be a negative 9. Negative 9 times 3i is going to be a negative 27i. Negative 27i times 3i is going to be negative 27 times 3 is a negative 81. But I times I is negative 1, so negative 81 times a negative 1 is going to be positive 81. Thank you. Positive 81 times 3i. What's 81 times 3? 241. 243. So this is going to be 243i. 243i times 3i is 729i squared. So it's going to be a negative 729. Negative 729 times 3i. Negative 729 times 3. And we're starting to get big. So it's going to be a negative 2,187i. Negative 2,187i times 3i. I know it's going to be real. And I know it's going to be positive. 6,000 what? 6,561 times 3 imaginaries. I know it's going to be imaginary. And 6,561 times 3 is 19 grand 683. Okay, imaginaries: addition, subtraction, multiplication, division. Let's start with this one first. So I need to multiply both these by 4. Distribute. 4 times negative 8 is negative 32. 4 times a negative 6i is a negative 24i. And then 3i times 3i is 9i squared. But I squared is a negative 1, so this is really a negative 9. And I know my negative 9 is going to play with my negative 32 because those are both real. So negative 9, negative 32 is going to be negative 41. And then that's my reals, and my imaginaries are just going to be negative 24 imaginaries. So those are easy. Now let's go negative 3 times negative 8, that's positive 24. Negative 3 times 5i is negative 15i. You got to distribute the negative with the 2. So negative 2 times negative 8 is going to be positive 16. Those are reals. Negative 2 times negative I is positive 2 imaginary. So now combine your reals. 24 and 16, 30, is that 40? And then your imaginaries, negative 15 imaginaries and 2 imaginaries. Negative 13 imaginaries. And this is the definition of a complex number. Complex has a combination of reals and imaginaries. So if you're combining reals with imaginaries, we're going to call that complex. Alright, this guy. 5 divided by 4 imaginaries. Just like it is unacceptable to leave irrationals in the denominator, if we can't have irrationals, we certainly cannot have imaginaries. So you're going to make the denominator real the same way you make the denominator rational. So you're going to multiply this fraction by 1, and you're going to multiply it by the square root of 3, because the square root of 3 times square root of 3 is a perfect square root of 9, and that is a rational number. So your top is going to be 5 square roots of 3, your bottom is going to be 3. Now, you treat the imaginaries the same way. So you're going to multiply this fraction by 1. And I'm going to multiply it by I. Because if I multiply my tops, 5 times I is going to give you 5I. On the bottom, 4I times I is going to be 4I squared. But you designed it because you know an I times an I is a real. So your final answer should be 5I on top and a negative 4 on bottom. So now your denominator is a real number and you're satisfied. And 5I over negative 4, that's the same thing as negative 5I over 4. So you can write it that way. Or it's the same as negative 5I over 4 with the negative out front. Okay, now let's look at this top left, because this one is the hardest. Okay, now this one's tough because you have 2 terms in the bottom. This term is real, this term is imaginary. You must multiply by the conjugate. So I'm going to multiply by 1, but your 1 is going to be kind of unique. It's not going to be negative 8 minus 10i. It's going to be negative 8 plus 10i. That is the conjugate. So I got to times the top by negative 8 plus 10i. So my top is going to be 4 imaginaries times negative 8. That's negative 32 imaginaries. 4 imaginaries times 10 imaginaries is going to be 40 imaginaries squared. On bottom, I got to distribute. And because you chose the conjugate, there's going to be a lot of stuff that cancels out. Negative 8 times negative 8 is positive 64. Negative 8 times 10i is negative 80i. Negative 10i times negative 8 is going to be positive 80i, and these will zero each other. So those imaginaries will zero out. And negative 10i times 10i is going to be a negative 100i squared. But I squared is a negative 1. A negative 1 times negative 100 is a positive 100. Positive 100 with a positive 64. On bottom, we got 164. On top, I squared is a negative 1. Negative 1 times 40 is negative 40. So you got negative 40 minus 32i. And these numbers are all even. 40, 32, and 164. Divide them all by 4. I know. Let's try to divide them all by 4. So that's going to be a negative 8. Oh, wait. That's negative 10. If I divide that by 4, it's negative 10. If I divide this by 4, it's going to be, what is that? Negative 8. If I divide 164, what's 164 divided by 4? That is 41. And I don't think 10, 8, and 41 have anything in common, so I think it's simplified. Alright, now if you're looking at a picture, so this function right here, 2x squared minus 12x plus 21. It's a quadratic function, and here is its picture. Here's its graph. So if the question is, when is this graph going to give you a 3? Or when will 2x squared minus 12x plus 21 equal a 3? So it's easy to tell if you're looking at a graph. They are asking you, when is the y going to be 3? So you come up here on the y, come up 3, and I want to look and see where my y is 3 crosses my parabola. And the answer, it crosses it once, so it crosses it right at 3. So if there is only one intersection, that must be happening at the vertex. Let's look at this next one. When does it cross at 1? It crosses at 1 2 times. Once to the left of the vertex, once to the right. So x is going to be 2 or 4. When does it cross at -5? -5, it crosses twice. Crosses once at x is 1 or x is 5.